Alright, let's talk about home delivery from CodeChef. So in this problem, we have Chef who wants to start a home delivery from his restaurant. However, he wants to like optimize the time. So he has identified a special type of bi-directional road, which he calls fast roads, which he plans to send orders to locations A and B together if only it is possible to travel between A and B using only fast roads. Your task is to find which orders can be sent together. Given Q queries that has two numbers X and Y that indicates those two, and you want to see if those two can be put together as like you if you would have a order from X and Y. Like, sorry, let me reiterate this. So yes, they did use the variables a little weirdly, but what he's saying is for Q queries, they want to check if X and Y orders can be sent together. And the only way for X and Y to be sent together is if X and Y are connected by fast roads. And this problem is obviously a graph problem. Okay, let me just get a paint open just to show you what they mean by. Okay, sorry. Also, note that because it's bidirectional. Okay, because it is bidirectional. Okay, ignore the background noise. That's my little brother playing Roblox. Uh, so in this, so let's say you have these. Oh yeah, and let me just get back to saying about the bidirectional part. Because they're bidirectional, if you can go from A to B, you can go from B to A, assuming there's a connection there. Okay, what this problem is saying is that you can only go. Let's just label these 1, 2, 3, 4, 5. So in this, we see that 1 is connected to 2 and 3 because you can go from 1 to 2 to 3. So 1, 3 would be a pair, and you would put yo in this case because apparently yo is what you would write if you can go, if X and Y can be put together as an order. However, 2 and 4 2 and 4 is a no because, as you see here, you can't go from 2, and there's no matter which road you take, you can't get to 4. Now that we defined that, what we can just do is just a basic that first search. We already created videos on this, so okay, editor, like Anakin, could you like put those in the link, or, like in the description, or do that thing do the thing where you put the end of the YouTube video where put the videos on the end. Anyways, enough of me chatting to the editor, assuming that he actually listened to this. We'll go. So we're gonna create a graph class, and we're gonna call it G, and we're gonna create a array list, adjacency list representation, and we set up our graph. We have our add, which because it's bidirectional, as I established earlier, if you can go from A to B, you can go from B to A. Then we're gonna create a DFS that goes from root, that has root and visited. We're gonna set. This is just a regular DFS. Okay, there's nothing special. How we implement this is different. Okay, so we have a fast scanner. Oh yeah, this is important. You need to create a scanner class that uses buffer reader and string tokenizer. And in order to do that, you gotta import java.io and then set up fast scanner with BR and set it as a new buffered reader with the input stream reader being system.in. Next, okay, while string st is null or it has no more elements, we're gonna create another string tokenizer that reads the next line, and then otherwise we're going to print stack trace because this follows IO exception. Like if there's no like extra lines, it's just gonna stop. And then return st.next token. And then we're just gonna parse int next. So now that we got that, we create a fast scanner with T test cases. For every test case, we have N and M, which n represents the nodes, and M represents the each fast road, and want to create a new graph. Then want to add all of our nodes or all of our edges, all of our m edges, which represents our fast roads as a structure. We have q queries, but first we want to create an array list that's called connected that contains Boolean arrays. Now this is important because what this is going to do is instead of DFS that first searching through every single query, we're just going to do it for every single value and see from every node which nodes can it travel to. And we can tell this by using the visited array. By using our visited array, which we call V in this case, when we run that first search, the visited array contains all the values that has been visited by a true or false. If the value is true, that means you can go from node I and visit node like whatever as long as it's true. So for example, if we have, or in this case, 1, so in our array list, so it's called connected. Our array list is called connected. Just call it C for now. And C.get 1, sorry, get, and C.get 1, number 2 is going to be true. This is going to be true. However, C.get, let's say C.get, oh yeah, in this one we're referring to this node and this node. So 1 can connect to 2. We can go from 1 to 2. However, C.get 2, 4 is going to be false. Meaning that you can't go from here, this node, to this node. Now that we've established that, we DFS for every single node and see and check for all its connections. And we're going to add V, or Boolean array, to our array list connected. Then for every query, we're going to check if the two are connected. If X is connected to Y. If it isn't, we're going to print no, otherwise we're going to print yo. And as you see, accepted. Now, thank you.